Momentum. Momentum is defined as the product of mass and its velocity. Momentum is equals to mass times velocity. Unit is kilogram meters per seconds or newtons seconds. Momentum is the property possessed by a moving body. Momentum is used to change the direction of the aircraft. Momentum diagram. U is the initial velocity, V is the final velocity, M is the mass, F is the force, T is the time. Impulse. Acceleration A is equal to V, which is final velocity minus U, initial velocity, all over T. F is equal to M in bracket V minus U all over T, which is the acceleration. Cross multiplying, you have that Ft is equal to mv minus mu. Impulse is equal to change in momentum. Change in momentum is equal to mv minus mu. Force F is equal to mv minus mu all over t. This is the rate of momentum change. Ft is equal to mv minus mu is equal to momentum change. The quantity or product Ft, force times time, is known as impulse or force on the object. The unit is Newton seconds. Principles of conservation of linear momentum. This states that if an external force acts on a system of colliding objects, the total momentum of the objects remains constant. Thus, if A of initial velocity u1 moves with a reduced velocity v1 after collision, and B of initial velocity u2 then move with an increasing velocity v2, we have that m1u1 plus m2u2 is equal to m1v1 plus m2v2, where m1 and m2 are mass of two colliding bodies. Newton's law of motion. Law 1. Every body continues in its state of rest or uniform motion in a straight line unless impressed force acts on it. Second law. The change of momentum per unit time is proportional to the impressed force and takes place in the direction of straight line along which the force acts. Force F is equal to mass m times acceleration A, or F is equal to ma. Third law. Law 3. Action and reaction are always equal and opposite. Example 1. A rocket expels gas at a rate of 0.4 kg per second. If the average force of the gas is 120 Newton, calculate the velocity of the gas. State the law used in your calculation. Solution. Force is equal to mass m of gas expelled per second times velocity. Force F is equal to mv, which is equal to 0.4 times v, which is equal to 120. Therefore, v is equal to 120 over 0.4, which gives us 300 meters per second. The law used state that the rate of change of momentum equal to the impressed force and take place in the direction of the force. Example 2. If a force of 6.0 Newton acts on a body for 5 seconds, what is the change in momentum? Solution. Change of momentum equals to impulse, which is equal to force times time, which is equals to 6.0 times 5, which gives us 30 kilogram meters per second or 30 Newton seconds. Example 3. A body of mass 2 kg moving with a velocity of 5 meters per second collide with a stationary body of mass 1/2 kg. If the two bodies move together after the impact, calculate the common velocity. Solution: momentum before impact is equal to m1u, which is equal to 2 times 5, which gives us 10 kg/meters per second. Momentum after impact is equal to m1u, which is equal to m1 plus m2 v2, which will give us 10, which is 2 plus half v2. Therefore, v2 is equal to 10 all over in bracket 2 times 1 over 2 to give us 4 meters per second. Therefore, common velocity v2 is equal to 4 meters per second. Note, momentum before impact is equal to momentum after impact. Example 4. A gun of mass 2.0 kg fires a bullet of mass 1.6 times 10 raised to power minus 2 kg. Do is: what is the required velocity of the gun? Solution: from law of conservation of momentum, Ft is equal to mv minus mu. The total momentum, which initially was 0, unchanged by the explosive impulse, taking the direction of the bullet as positive, we have that 1.6 times 10 raised to power minus 2 times 150 plus bracket minus 2v, which give us 0. 2.4 minus 2v is equal to 0. V is equal to 1.2 meters per second due west. Example 5. If a mass of 50 kg moves a velocity of 36 km per hour, calculate the time taken to bring it to rest by a constant force of 100 Newton. Solution: since we want to convert the kilometer per hour to meters per second, we divide 36 km per hour with 60 times 60 and times it by 1000, which will now give us 10 meters per second. Initial moment is equal to mass times initial velocity, which is 50 times 10, which give us 500 kg meters per second. Final moment is equal to 0. Since force times time is the moment change, therefore 100 times t is equal to 500. Therefore, making t the subject of the formula at the time, we have 500 over 100, which will give us 5 seconds. Example 6. A 15-gram bullet traveling at 300 meters per second strikes and it's absorbed by a 75 kilogram object. Find the speed with which the object moved off. Solution: sum of individual momentum of the bullet and the object before collision is given by m1u1 plus m2u2, which is equals to 15 times 10 raised to power minus 3 kg times 300 meters per second plus 75 kg times 0, which give us 4.5 Newton seconds. The mass of object increased after collision. Therefore, the momentum of the system after collision is in bracket m1 plus m2 close bracket v, which is equal to 0.015 plus 75 kg in closing bracket v. From conservation of linear momentum, we have that is 4.5 from before sum of momentum before collision. 4.5 Newton seconds is equal to 75.05 kg. That is the sum of momentum